So we're going to talk about systems of linear equations. We have talked about linear equations, have we not? Linear equations are equations when you graph, you get a
straight line.
You get a line.
Linear.
And so what about those points that are on the line? What are we really graphing when you're graphing linear equation? You are graphing all the, yes. Yeah, what are all those points, order pairs? What are they? They are the, raise your hand. Slope. No, slope is the ratio of rise over run of that line. But when you're graphing, those lines, right? When you're graphing a line, each of those points on the lines are the solution of that linear equation. You guys remember that? Okay. So today we're going to talk about systems of linear equation. And one of the way of solving systems of linear equation, whatever that is, we'll explain that what that is in a minute, is the way to graph it is, to solve systems of linear equation, one of the method solving it is called graphing method. That's what we're going to learn. Do you think there are many other methods than graphing? Yeah, so one of the method of solving systems of linear equation is called graphing method. Does that make sense? That's what we're working on. So let's kind of review. Before we had an equation. We had an equation that looked something like this. Y equals to mx plus b. This was a linear equation. And what did the solution look like when you have something like this? Yeah.
Like the slope and x is the y-intercept?
Yeah, that's how you graph it. Using the slope and the y-intercept, you graph the line. And so the solution of this linear equation, which just as we said before, is a line. Bunch of points that form a line. You guys remember that? So write this down. Our solution was set of points that form the line. You guys remember? Because there were infinitely many solutions that make that equation true. Right? And if you were to plot everything, it forms a line. Okay. So what do you think then a systems of linear equation? It could be actually systems of any equations, but we're going to actually talk about systems of linear equations today. What do you think then a systems of linear equation is? Anybody any guess? We just talked about, yeah.
It's the way that you find a linear equation.
The way that we find, not quite. We've actually learned how to find linear equations and so forth. It's actually, yeah.
It's actually what?
Go ahead. What do you think?
The different types of linear equations?
Okay. It's actually, so here's the definition. So it's not really that hard. This is all it is. So when we talk about systems of linear equation, it just means two or more equations in the same variables from, it forms a systems of equations. Basically means if you have more than one equation, we just call those equations systems. So, what does that mean? Well, we could have how if I give you one equation, linear equation after another, and I ask you to solve those two equations, what does that mean? Like if I give you, for example, I could give you 3 or 4 or 10, but let's just talk about very simplest one, which is when you have how many equations? 2. If I have 2 equations, that will be systems of linear equations, right? If I give you 2 linear equations and I ask you to solve it, what do you suppose that means? Because we know how to draw these things separately, right? But when I say solve these both of them, as a system, meaning as a whole one thing. Yeah, Kevin? Not quite. Yeah, do you have an idea? Maybe the lines would intersect? That's correct. So what does that mean, right?
So they have the same vertex?
Same vertex? Okay, I think you're getting close. Okay, so first of all, let me ask you this question. What do you think the solution or solutions of systems of linear equation will look like? Okay, write that down. We know the solutions of one linear equation. We know what the solutions look like, don't we? What do they look like? They form a line, right? They're a bunch of order pairs, right? A bunch of set of order pairs that forms a line. But what about if I give you one or more equations, like for example, 2 equations of linear equations, and what do you think the solution of these 2 equations will look like? Anita? I'm sorry? I can't hear you. Two perpendicular lines? No, not quite. Solution of the two. So if I were to give you any two lines, what do you think the solution might be? Peko?
A point where they
It'll be a point where they intersect, just like Tina said. Do you understand? Why is that the solution then? You're right. If the two lines intersect, you know that point, for example, here. So, okay. So here's case one. If I have two lines, you see where the two lines intersect, that dot? That is the solution of the systems of these two linear equations. Why do you think that dot, that order pair where the two lines intersect, point of intersection, is a solution? Get it?
It's the only one where both lines have the same intersection.
Excellent. That's the only place where it is a solution of both lines, right? Isn't this point a solution of the one on the left and then the one on the right, these two lines? So that's the only place. Could it be like out here? Could the point be out here? Could it be on this like right line up here? Is that a solution to both of the lines? No, it is a solution for only one of them, right? So where is a place where it will be a solution for both? Where the two lines intersect. Okay, good. Is this the only possible case for two lines to be like do they have to intersect every time? No, what other case could you have? Yeah.
Parallel lines?
The two lines could be parallel. There are actually three cases. There are two lines could be parallel. What else? There's another actually. Yeah. If two lines are perpendicular, then they intersect. That would be case one. So just because they're perpendicular to each other, right? So it means they intersect. What's the third case? The two lines could be either intersecting or parallel or Kate, I'm sorry.
Like the same line.
If they're the same line, it's exactly right. So here are the pictures. Case two. Notice if the two lines happen to be the same exact line, right? Then how many places do they intersect? A lot, infinitely many places, right? Right? It is everywhere on that line, right? Does that make sense? What about if they're parallel? If two lines are parallel, do they intersect at all? No. So do you think we have solution?
No.
You think you have two solutions? If the two lines are parallel? The answer will be what? No solution is correct. If two lines are parallel, there are no solutions. So how many solutions do we get if they intersect? We get one. How many for if they intersect everywhere?
Infinite.
Infinitely many. And see right here, number of solutions. It's on the bottom. Okay. And how many solutions do we get for parallel? None. That's correct. No, it's not possible for systems of linear equation to have two solutions.
Because because they're all straight lines.
Exactly. All lines are straight. But what about parabolas?
You can have
What
a
about
few.
parabola and a parabola? Could you have two solutions?
Or like 5. If it's,
Parabolas? No, you cannot. You cannot have 5 for parabola.
can't you have like
No, if it's 5, then it's going to be the same exact parabola.
oh.
How can you have right? So for parabolas, you could have two solutions, right? If one of them is upside happy face, the other is sad face or something like that. Does that make sense? So if you're going to talk about different equations, yeah, it's possible. But for linear equations, these are the only three possible cases you could have. Either one solution where the two lines intersect, or no solution if they're parallel, or infinitely many solutions, right? Right? If they're touching like every point, right? Okay, so let me ask you this: What can you tell me about the case one in terms of the slope of the lines? If you have one solution, the slope of the line must be yes,
Opposite.
not opposite. No. Yes? No, not reciprocal. Yes.
Oh.
The same.
No, very wrong. Not same. If you have one solution, no.
Not the
Yes.
same.
Different is the right answer.
I said not the same.
Well, and if the two lines are, of course, the case 2 and 3, because you have the same line and parallel lines, slope has to be then same. Okay, so kind of think about what we're writing here. If the two lines intersect, the slope must be different. Okay, if they're same, of course, they'll either be same line or parallel. You see what I mean? So if you're gonna have one solution, you can kind of tell by just looking at their slopes. Two lines must have different slope. Okay, so write it down.
I said no, not same.